Yes.
Yes, sir.
Okay. Okay. So there, I can see that there are total 11 participants. So should we wait for a couple more minutes so that more students join and then we can start?
Sure.
Okay. Reply. Hello, Pooja. I just saw your message. Can you hear me?
Yeah, actually, I wanted to say like just 30 minutes ago, we got the access. So the live session info must not be available to many students who have not seen yet that they got the access.
How many students can you type in, let's say, yes or something so that I get an idea of how many of you got access to the course content today, 30 minutes ago? So basically what I'm trying to understand is it possible that all of you got the course access late? Got 1 p.m. today. Okay.
No, sir. So I received it on September 1st, 2nd itself.
September 1st. Okay.
Only those who have taken MLT and MLP together, I think they got today.
Oh, is it?
I have completed MLT last time. This time I have registered it separately for MLT.
Senthil, so when did you get the access?
Oh, last week, sir.
Last week. Okay.
Yes.
And you have taken ML techniques earlier, or you are taking it together this time?
No, last time.
You finished it last time. Okay.
Yes.
Okay. So Pooja, did you finish last time, or you are taking both of them together this time?
Together this time. So that's why I know, because many students who registered both of them today, they got access today, and some of them are still pending, I guess. They are getting today.
I see. I see. And what about ML techniques access? Did you get that access early also, or that also late?
That I got on 2nd September, but MLP, they had some test. I mean, there was some criteria. So after checking only, they are providing us. So today we got a mail that we got access. I just got 30 minutes back, like 3:30 or something like that.
Oh, okay. So those students who got late access, I would suggest that we continue with this session, but you can be present. I'll cover some of the things, but for you, this will be very, very new because you have not gone, you didn't get a chance to go through the videos, and therefore the activity questions that we'll be going through might not make sense to you as of now. Okay, so Pooja and Ravi, and those students who got access late. Does this sound okay to you? You can go through this live session since it is being recorded. Okay, okay, sure. Thanks, Pooja. Okay, so I hope you can see this. See my screen. I have started the. I've logged into my course page, and you can see that this is the introductory page. Is it visible to everyone?
Yes, sir.
Okay, okay, sounds good. So this is our machine learning team. 3 people will be primarily involved in ML practice course. Dev Jyoti, Jimmy, and Swarnim. That's me. So we 3 are primary instructors for machine learning practices course. And the study material will basically, there will be a bunch of things that will be covered, and couple of items which are present over here is, this is one book, Hands-on Machine Learning with Scikit-learn TensorFlow. So again, so TensorFlow is something that we are not going to cover, but Scikit-learn definitely, Scikit-learn in great detail. And second key resource for you will be the Scikit-learn user guide. So I just want you to look at this web page, because it basically has all the models that we will be discussing during this course, and we will be using Scikit-learn extensively. There will be no other machine learning library that you will be required to learn, only Scikit-learn. And all the fundamental models of machine learning and machine learning techniques that we need to work with are present in this library. There are linear models, perceptron, linear regression, support vector machines, nearest neighbors models, naive-based decision trees and sample methods. And apart from that, neural network also, but very, I should say, not the advanced versions of neural network, multi-layer perceptron, I think. And apart from these important models, you will also find APIs and techniques in this library, which can be used to clean data, pre-process data, so that it can be fed into a machine learning model. It can be prepared so that it can easily be consumed by any machine learning model. Okay, so that is one very important component, and it stands in contrast with machine learning techniques, where you assume that you have a data set which is very clean. It doesn't have outliers. It doesn't have missing values. It is sitting in one standard table or any standard format that you want it to be. You don't worry in machine learning techniques where it came from. You just assume that you have the model. Now you want to understand how to apply a model, and how the model works, how it is optimized, how it reaches the set of parameters for that particular model. But in ML practices, it will be absolutely different. You will get raw data sets which can come with all types of problems, like missing values, outliers, and so on, and you have to figure out how to get rid of them. And that process is called data pre-processing, which will be also covered in this course. Now let's get back to our course. So how many of you have gone through the videos?
Sir, I think not everyone got access to the course. So for example, I got access today itself.
Okay, I understand that point, but still, I mean, if by raise of hands or by typing something in the chat box, you can tell me how many of you have gone through the video, so that I get an understanding of how quickly I can cover this. Should I go slow? Okay. So for future reference, please make sure that before this first session, you have gone through all the videos and activity questions as well as practice assignments. You have at least taken a look at it, because that is what we are going to discuss in this first live session of the week. Okay. So I'm seeing in the chat box that some of you have gone through 4 videos, some of you have gone through 2 videos, and so on. So there are total 6 videos you can see here. I mean 6 important parts, and 6 plus 1 if you count this one. So total 6 or 7 videos, and then there are practicing area assignments. So let's start with activity questions from first video.
So just a quick question before
Sure.
we start.
Yeah.
So I did the MLT last term.
Okay.
And I believe that this term, the structure and the way and the professor who is teaching it has also changed.
Right.
And I believe the first 4 weeks is largely about unsupervised learning, including dimension reduction and all that.
Right.
So how will MLP then align with MLT, or will MLP just follow whatever was taught earlier? Is there any? I mean, are there any additional stuff that's brought into MLP this time?
Okay, so I'll tell you a couple of things. One thing is ML techniques earlier was core requisite for ML practices, but now it is prerequisite. So since this change is happening and your batch is the batch for which this change has happened, so you got a chance to maybe since you have already taken ML techniques earlier, but since they were earlier, they could be taken together. And this is the last term when any student has the opportunity to take both the courses together. Later terms, in later terms, students will not have this opportunity. They will have to take ML techniques first, complete it, and then enroll in ML practices. Okay, so now this is a change. Since earlier it was core requisite, that means there was an alignment because students taking it together. Yes, of course, the topics had to be week-wise, the topics had to be aligned. But now, since ML techniques is prerequisite, there is no requirement for such an alignment. Does it make sense?
Okay. Yeah, sure. But still, some of the unsupervised learning aspects like dimensionality reduction will be covered in MLP, or it won't be?
It will not be covered in that detail.
Okay.
Yeah.
Okay.
Because see, I'll tell you why. When you're talking about unsupervised learning, there are PCA, kernel PCA, and clustering. I can think of only these 3 items. And all these 3 will be, they are implemented in inside sklearn in an API. So all the algorithms that you have studied for these 3 techniques, they are very valid. They are very useful. In ML techniques, you will learn them from the inside. But however, in ML practices, you will just import an API corresponding to one of these 3 techniques and just use it. It is assumed that you know the internal details, what goes in, what goes out,
right?
And that's how it will be. You will not look inside a model.
Internals of it. Okay.
Yes.
Got it. Okay. Thank you, sir.
Okay, sure. Any other questions before we begin?
Sir, I wanted to ask that since this is the last term in which students are getting the opportunity to have MLP and MLT together, but like definitely MLT was a prerequisite to this course. So how we can, what we can do to add to our learning to get maximum out of MLP? Like right now you were speaking about that now there are APIs, but we are expected that we already know what's the internal process that's going behind. So how are the students that have not yet taken the MLT course are supposed to know that, and what they can do in order to aid that?
See, so if you're taking ML practice and ML techniques together in this term, is it?
Yes.
Okay. So first of all, I would highly encourage you not to do so. If you have time, I would suggest you to take ML techniques first and then ML practices. because in ML practices, you will see that, for example, in week 3 and 4, when we will talking about regression problems. Okay. It will be assumed that you know all the regression models, including decision trees, ensemble methods, support vector machines, and so on. Right? Everything, every model that can solve a regression problem. Because when we are trying to solve a problem, a regression problem, the problem is free. Hello, am I audible?
Yes, sir.
There was some kind of disturbance, right?
Yeah. I think someone was trying to say something.
Okay. So let's leave that one. So what I was saying is,
That by week
for example,
yes,
by the time we reach at regression problems, it is assumed that you know all the regression models, not just linear regression, perceptrons, basic ones, decision trees, and sample method, support vector regressors also. So, but if you're taking ML techniques together, decision trees and ensemble methods will come very, very late, and you might not know how they work. Okay, so you might feel a little bit, I should say, unfamiliar with the models that you are working with, right? So that's one thing. But if you are still bent on taking both of the courses together, then in ML techniques, last term's videos, they are already available, and you have to watch them. Okay. To prepare yourself in week 3 and 4 for the models that might come later in ML techniques this term, or you want to refer to other resources which are available online. So you have to, you will have some catching up to do for ML practices. If both you are taking both of the courses together, if you're taking both of them separately, then it's fantastic. Then you have no worry, nothing to worry about.
Okay. Thank you.
Okay, sure. So I would still suggest that I would strongly recommend to take ML techniques first, finish it, and then take ML practices, not both of them together in this term. Since this change happened this term, the students have this opportunity to take both of them together, but not recommended.
Excuse me, sir.
Sure.
Sir, I had a question regarding the last previous MLT lectures.
Sure.
Sir, those lectures, like, we can still view them, right? Because they are only assuming that we know MLF and nothing more, right?
Right.
Okay. Thanks.
Sure. So they are publicly available in public domain. You can get the link of the MLT lectures in Discourse, I think.
It's on YouTube itself.
Yeah, YouTube, and the link of list of all the videos in ML techniques you will find in. I think somebody who has taken the ML techniques course can confirm this.
Sir, there's just one more request that
Yes.
Since we have a lot of catch up to do, so can you please, like, before each week, can you just suggest that, okay, these are the lectures that might help you?
Well, okay. So before the week starts or during the week that you want it?
Yeah, before the week, so that we can, simultaneously go forward with the lectures from MLT as well as MLP.
Like, just as a heads up, so you have to revise these topics.
Okay, so I see. So I can tell you right now, okay, all the models that we are going to cover. I think you can look at the syllabus of ML techniques course. The syllabus has been reorganized. It has not changed. That means the order of topics has changed, but the content itself, it has not changed more than 5%. Okay. So, for example, if you're talking about regression problems, you can think of all the models which are relevant for solving the regression problem. You are supposed to know them. For ML, for classification, again, you are supposed to know all the models which can be used for classification problems. Okay, does it make sense?
Yes, sir. So next we will check the syllabus, and if there is still any problem, we can get back to you.
Sure.
Thank you, sir.
Okay.
And just one final, one short question. How different is TensorFlow from sklearn? I mean, I know we are going to learn sklearn extensively, but industry also uses TensorFlow and Keras and all of that. So if we learn sklearn, does it give us a good basis for us to just, is it like learning one language properly, therefore you can learn another language quickly from there, or how different is it?
Okay, so my answer might not be very accurate because I'm not familiar with TensorFlow as much as I am familiar with scikit-learn. So TensorFlow, both of them, scikit-learn and TensorFlow, both of them are very good machine learning libraries. TensorFlow was originally designed to solve problems with neural networks. So it is very neural network intensive. You will see all the latest well-established techniques, algorithms for training neural networks, different types of models, for example, CNN, RNN, LSTM, and all those. You'll find them in Hello?
Hello, I briefly lost
Yes,
you,
sir.
sir, and I can hear you now.
You're audible now.
Okay, so that is
I think we lost you again.
one difference in of other APIs also for data ingestion and other stuffs. But so to be honest with you, I'm not very familiar with TensorFlow, so that's all I can say as of now.
Okay, sir. No worries. Thank you.
So if you're interested in taking TensorFlow, you have to learn about it. I think there is a course on TensorFlow from that is also taught by Ashish sir. TensorFlow.
Sir, I think your internet may be slow.
Yeah, even the screen share is freezing up.
Okay, give me 1 minute. Is it visible now?
Yeah, it's visible now.
Yeah, it is visible, but it like freezes up at times.
Okay, maybe some network issue. So I think this is the course. There should be some list.
Sure, sir. I'll look it up. Okay, now there's a course. Yeah, we can certainly look it up.
So your screen is freezing.
Yeah, this is the one. So I'm pasting its link in the chat box.
Thank you.
Okay, sure. But take it with pinch of salt. The reason I'm telling you this is this course was offered in 2019. I don't know, must have been recorded before 2019. And TensorFlow since then have launched a new version of its library. So, okay, so definitely some of it will be useful and some new things may not be here in this course. Okay, let's get back to our course, ML practices. Am I audible? Should I begin solving the questions now?
Yes, sir.
Yes, sir. Yes.
Oh, okay. So first question is about data snooping. So we have to choose which of these 4 options or more than one option might be also correct. So first option is leads to biased estimation on test sets. Second is increases the risk of false positives. Third is leads to better estimation on training sets. Fourth is reduces the risk of false positive.
First two.
Sorry, I could not hear that.
First two, right?
Right. I also think so. What do others say?
The data snooping is where basically we look at the test data set and have some kind of a view of what the, instead of just keeping it aside and not looking at it while we train.
Right.
We take a look at the test set, then we are biased by the data that we have in the test set. That's what it means, right? Data snooping.
Absolutely right. Absolutely right. So yeah, you explained it properly. So data snooping is looking at the test data set when you're not supposed to. You're never supposed to look at the test set and get some kind of idea or insight into test set and use that idea into training your model. That is data snooping. So it leads to biased estimation on test set. That is absolutely right. So somehow you have trained a model so that by knowing some information from test set, your model is obviously going to perform better on test set, but it is going to give you a biased estimation on its performance, because test set is supposed to be a real world data set which you have not seen at all, right? But since you have already seen it, it is going to give you biased estimation of performance.
So
Second,
what about training
yes.
set? So what about training set? Like, will it give a good prediction on that?
Third option?
No. Like on test set, like there will be a bias estimation. But what about the training set? Like, what will happen with training set? Will it give a good accuracy rate or something?
See, for training set is already available to you, right? So you can always look at the training set and figure out why it is not working. Any model is not working well. What are the misclassified samples, or the number of the samples on which you're, for example, if it is a regression problem, the samples for which the error is too high, RMSE is too high, or some other metric which you are using. So I mean, it is data snooping is not going to affect your performance on training set. Does it make sense?
Yes, sir. Because we like always check the training set. Like it's just a test set that we don't see, right?
Sorry, your voice is not clear. Can you please repeat your question?
Yeah, like I was saying that we always look at the training set, but we don't look at the test set. So
Right.
that's why, right? And when we see the training set, we can, do tuning of hyperparameters and try to make it accurate.
Right.
But on test sets, we cannot do that. We just test it on those test sets. So I think that's.
You think what? What is the question exactly?
No, I got it now. Like what you explained.
Okay. Okay. Sure.
So does it also lead to false negatives?
I leads to better estimation.
No, it's not in the options, but just asking.
False positives. I think
false,
it is
false negatives.
False negatives. I think it should false negatives, right? It possibly can, because you're training your model on test set basically. On test set, it is going to perform. It is going to give you very good accuracy or very good FN score for classification tasks. But when you see the actual performance on real world data set, yes, it can increase the risk of false negatives also.
Okay.
Right. Okay. Any further questions, or should I go to question number 2?
Can you little explain, sir, about that increasing the risk of the false positive? So why? So this is from the confusion matrix, is it?
Right. It is from the confusion matrix.
So why I am talking that only one portion of that? So there is a 4 possibility in the confusion matrix. So why increasing the risk of false positive? Why not true positive, true false, or the false positive?
Okay, true. So basically, what we are doing is we are possibly overfitting our model, right? By data snooping, our model will be will have some insight into the test set which our model is not supposed to, right? So most likely our model is overfitting, and in case it is overfitting, both the options, our estimator is going to be give you good performance on training phases on test set also, but not on the real world, and it can increase the risk of false positive in the real world, right?
Okay, so is there any relation between that, like we say that overfitting or underfitting with the confusion matrix?
Yes, we can say that, right? With the help of proper parameters, confusion matrix is one way to evaluate any classification model, and definitely it can help you to decide whether your model is underfitting or overfitting.
Okay, so my question was specific that suppose I know that that particular my database or the training data or the something what I trained is the overfitting. That's I know. So before creating that confusion matrix, can we predict that confusion matrix this particular section is going to be more or the increase the risk of the false positive?
Okay, so first you have to tell me you have to tell me how did you figure out that your model is overfitting without looking at the confusion matrix or any evaluation criteria.
In that case, I can say simply that see, in general, we can say that if overfitting is there, then more than 80 or 90% I'm getting the correct on the training set, and testing we will 2-3 I will predict and I will get that false type of observation, but I'm not creating the confusion matrix. That's normal when I'm taking the training and going on the testing.
Sorry, I didn't understand the question. So you're saying that your model is doing good on 80%, let's say, on training set, and 2-3% on test set. Is that what you're saying, right?
Yes. So whenever we say that it is overfitting, that means most of thing I'm getting correct in the training type of that. It's our parameter is validating the all the variable. And but in the
performing
test,
poorly on test set, right?
Yes, it is not going. But to get the confusion matrix, I have to know that entire set of all the 4 combination.
Yeah, so once you have trained the model, you can create the confusion matrix for both training set as well as test set, right?
Yes. So here the question was they increase the risk of the false positive. That means we know that what is going to output of our confusion matrix. So that's my question was there. Can we predict after seeing that particular thing, this is going to be predict what in confusion matrix?
So you can guess, of course, yes. This second option and confusion matrix are very closely related. Yes, we can say that. Hello?
Okay.
Okay.
But so like here, I just want to clarify one thing. On test set, it gives a good accuracy rate, right? Is it right?
Sorry, your voice is dropping in between.
I'm saying on test set, we get high accuracy, right? Like they're more true positive and true negatives when we do data snooping.
No. So see, false positive is something which is not positive, but our model is giving it a positive value.
Yes, but like that is for the data which is unseen. But what about the test set? Test set, that is the data we have seen. So it will show good accuracy on test set, right?
Right. You are actually right. I think option number D should be right instead of option number 2 in that case, right?
I think in second option, they're talking about the other data set, like world data set, not the test set here.
increase the risk of false positive.
Yeah, on other data set, not test set, I think.
Right, you're absolutely right. So both option number 2 and option number 4, even option number 1, right, option number 1. All these 3 options are talking about data sets which the model has not seen, neither a training set nor the test set. Reduces the risk of false positives. I think this should be the correct one, since it is already
so this is the correct option, second one.
okay. Reduces the risk of false positive. This will definitely happen on the test set, but will not happen on the unseen data. And this one increase the risk of false positive. It is also happen on the unseen data. Okay, let's see which option is the correct. Or have you checked these?
I've checked it.
Okay. Then definitely it must be talking about the data set which has not been seen before. Okay. Then should we go to the next question then? Is your question answered? Is it clear?
Yes, sir.
Okay, let's look at the question number 2. Which of the following statements are correct? Random sampling randomly selects k number of points as the test set. Random sampling randomly selects k % points as the test set. Stratified sampling samples test examples such that they are representative of overall distribution. Stratified sampling samples test examples such that they are representative of the training set. Which of these 4 options are correct?
Two and 3.
Okay, so let's take a look at this. Random sampling. I think it is referring to train test split API. Am I right?
Yes, sir.
Yeah, it has been mentioned in the video also, and that is very popular, very useful API to split your data into test and train sets, so that you can train your model in training set and evaluate its performance on the test set. So by default, it accepts a percentage, a value, a fraction between 0 and 1, so that it can choose what will be the division of train and test set. So it selects a percentage definitely. The other approach. Hello.
Yes, sir. You're audible.
Someone was asking a question. Hello. Okay, I think I'll.
Yes, sir, I was. Sir, am I audible?
Yes, you're audible.
Sir, in first question, how will it increase the risk of false negative? Because we are overfitting the points. So.
Right. See, whenever you're which it depends upon the classifier also. So for a minute, assume that you are using logistic regression. Hello.
Yes, sir. Yes.
Okay. Or you can even assume KNN. But for a minute, let's just assume logistic regression. So it is going to make both kinds of predictions wrong. So imagine you have a classifier which has to distinguish between 0 and 1 classes, positive or negative, right?
Yes, sir.
Right. If it is going to increase the, if it is going to make wrong predictions, it is going to make wrong predictions of both the classes.
Yes, sir. So how it will increase it? So it will be wrong, like it will not increase. It will miss out those wrong predictions.
False negatives, right? See, overfitting is going to, an overfitted model is going to make wrong predictions in both classes, not just one of them.
Okay. Oh,
Right?
I got that.
Yes. All right. Now coming back to our questions. Question number 2, stratified sampling. Of course, stratified sampling makes sure that the test and training sets have similar distributions to the overall distribution in the data set. So option number 3 is correct. Okay. So can anybody tell me what is the importance of stratified sampling? Why can't we do just random sampling?
It averages out outliers.
The answer is not in terms of outliers, something else.
The distribution of data also.
Absolutely. So imagine, yeah, you're absolutely right. So imagine that the positive class has only 1% of samples and 99% samples belong from negative class. If you do the random sampling, it is possible that your training set doesn't have any single positive class, right? So that is the problem, correct? Or since it is only 1% of the positive class samples, it is possible that all of the 1% positive class samples might end up in either in training set or in test set. In either of the cases, it is really bad for the model to be trained. So you want to make sure that the distribution in both the sets is same for both the classes, and hence stratified sampling is really important.
But it can lead to some bias, right? Because if in case of an unbalanced data set, I mean, it will forcefully bring about the same percentage of the same classes in both the test and train. Whereas in real life, it may not be the case, right? The unseen data may have a balance different from the train set.
That is absolutely right. So unseen, that is one thing. See, unseen data, nothing can be assumed about, but it can definitely, for example, you're talking about, let's say, cancerous predictions. So you have an image or some kind of sample, and you want to decide whether that cell or image has tumor or cancer or not, right? In real world, you will always observe that 1%, 2%, very small number of samples will belong to positive class, and most of the samples, rest of the samples, 99 to 98% will belong to negative class. That is, there are no cancerous cells or tumors. Correct. But when you have a data set, there is no other assumption that you can make. You cannot train your model based on the current data distribution for a distribution which you have not seen, right? Right. So for training your model on a data set, you'd always want to do stratified sampling if there is imbalance in the class.
Okay, sir.
Okay. Question number 3, mentioned true or false. Stratified sampling gives this test distribution closer to the overall distribution as compared to the random sampling.
True.
True. That is true. Let's check the answers. Yes, all of them are correct.
Sir, are there any pros and cons of stratified and sampling?
Cons, I cannot think about it. It is actually alleviating a problem that random sampling has. Hello?
Yes, sir. Yes, sir.
Right.
But it won't it take more time? Like
no, no. Computationally, it is not expensive. Not expensive at all. Yeah.
For the regression problem, stratified sampling won't work, is it? Because
yeah, stratified sampling works for that only classification.
Only classification.
Right. Okay. So should I move on to next set of activity questions?
Sure.
Should be the first one.
Right. So question number 1 is the function dot is NA is used for which of the following purposes? Okay. To detect missing values, not a number. NN stands for not a number. Second, to generate heat map. Third, to generate scatter plot. Fourth, to plot standard deviation of available data in the place of NA values. So right, dot is NA stands for, I think, is not available or is not a number. Is not available. So first, I think this is the correct option. It is used to find out if there are any absent or missing values in the data set.
So
Yes.
So even categorical values like text string or Boolean values, does it include that?
See, so NaN is a special value. It's not space. It's not question mark. It's not nothing else. It's a special value numpy.nan, which if it is present in any of the data, any of the columns or any of the rows, it will be this dot is NA is going to figure that out. So yes, it works for both, all of them, Boolean, strings, integers, as well as floating point numbers.
But not special characters.
Special characters are also strings, right?
Okay, yeah.
Oh, sorry. So what you're saying that there is a special character, let's say question mark in the data set for missing values. Will it figure it out? Is that your question?
Yes.
No, it is not going to figure out. Okay, the question marks have to be replaced with numpy.nan or something else, or some. So imagine that you have used question marks in your data set for missing values that you did not know. Okay, then in order for this function to work properly, those question mark values have to be replaced with numpy.nan before you do any kind of pre-processing. Okay, does it make sense?
Yes, but like how do you convert it to numpy.nan?
Numpy actually, okay, so you can use Pandas replace function, okay, to replace a string with another string or another value in the entire Pandas data frame. Does it make sense?
Yes, and one clarification, like this question mark you're talking as in like that it is a string, like
right
in a string. Are you saying
right
that?
Right.
Okay, so all strings won't work. Like special
Right.
character strings won't work.
Special character strings, I mean, you must have in your data set use some of the some either blanks or question marks or some set of values, some set of strings to represent empty values, right, or missing values, correct?
But they are not strings, right?
They can be strings. A question mark, if it is present in your data set in a data frame, it will be stored as a string.
But these special character strings have to be converted to numpy.nan. But
replaced with, not converted.
Okay, so replaced. But strings, Boolean numbers do not need to be replaced.
Well, the other good values you want to keep, the garbage value you want to definitely replace.
Okay, yeah, makes sense.
Okay. All right. Okay, let's move forward to next question then.
Sir?
Yes.
So meaning is dot is NA is not going to respond to any places where we have not entered any value?
We have not entered any value.
Meaning
if it is yeah, okay.
Empty.
So by default, if it is empty, then actually Pandas can take care of it. But in case somebody used a question mark or some other kind of symbol or a string, then it will not take care of it. Dot is NA cannot read that. It is going to assume that question mark might be a useful value for the data set.
Correct. So we have to like take care of that manually. We have to check the data.
Right. Definitely, you have to check that manually. So there are pandas functions, for example, unique and unique. For example, for any particular column, you want to test out how many unique values that column has. Then you can definitely write column data frame in bracket. We choose the column dot unique, and it's going to give you the list of unique values in it. And by looking at that, you can by observing that set of values, you can figure out if it has missing values or not.
Yeah, correct.
Okay, and also you can look at the data type of a particular object or particular column. That can also help you figure out if it, for example, a numerical feature is supposed to have all the values as either floating point or integer, right?
Yes, sir.
But assume that it is represented by object, which is a typical data type for any string value in pandas. Okay,
yes,
so when you see an object data type for a numerical feature, you might think about, okay, something is fishy, something is not right, it should be numerical. So you want to inspect it further, and you might find that some string values are entered over there which is not supposed to be there. Then you decide what to remove them, change it to something else or something else. Okay.
Sir, for to check the data type, we use the command .d types, and that or .info that gives us information about the whole column, that this column is supposed to take this value. So how will we judge that, okay, in this column which is supposed to take, for example, int values, it has it has an object value?
So first of all, it is supposed let's say you have a cast data set, and one column is number of seats. Okay, number of seats is supposed to definitely be numerical.
Yes,
right, integer. Then you see that it is supposed to be a numerical feature, but you are seeing object. You want to inspect it further. You want to look at the unique values and see what's happening. Right?
Yes, sir.
Okay. So when pandas reads CSV files or data sets, then it automatically tries to infer the data type of the columns.
All right.
Yeah.
Okay, sir. Thank you.
Okay, sure. So this kind of situation definitely occurs, that dot is NA is going to give you that there are no null values, but there are some garbage values that you want to replace with man. So we'll see exercises for that. I think from week 2 onwards. Okay, so moving on to question number 2. Which of the following methods from pandas may be used to drop rows containing missing values?
So first one.
Right. So this is more like memory based, and that drop NA is the method that you use. Question number 3. Mention true or false. sklearn provides simple imputer class for filling up missing values or not. Whether it is true or false.
Yes.
It is true, and actually I can go. It is slightly giving you a peek of what is going to come to you. Here is the sklearn simple imputer API. It's inside impute. Impute means fill the missing values, and there are few types of imputer APIs available: simple imputer, missing, knn imputer. These two are very important ones. We are going to show you both of these. Okay, let's.
So this is more scientific than the fillna command, right? Because fillna is just, I mean, just fills with certain value like false or true, right? This is better, simple imputer class.
Right.
There's a command called fillna, I think.
Yes, fill NA is there. In simple imputer, there are better imputers than simple imputer. One is knn. The other, another imputation method that you can use is you can actually use an estimator, for example, decision trees, or probably one of the ensemble methods to fill missing values. It's slightly advanced, but we'll come to that part also. So anybody can tell me what is simple imputer? What does it do? It fills the missing values. That is true.
So it, based on the methods that we use, we could use median value or average or something, and based on that, it fills up the missing values.
Absolutely right. For numerical columns, that's what we can do. For categorical columns, we can either go with a fixed value, or we can go with the mode. I mean, the most popular or most frequent value inside that column. We can use that as well for categorical features. Okay, so let's move on. If you do not understand this in great detail, don't worry about it. Simple imputation, filling missing values, they will come in detail next week. Okay, question number 4. Fit transform method on ordinal encoder object is called for which purpose? Convert numbers to text, convert text to numbers, convert decimal to binary, convert real numbers to rational numbers.
So what is an ordinal encoder object?
Good point. So okay, before we talk about ordinal encoder, I have to tell you that any machine learning model can only accept numbers. Okay, it does not understand a string. It does not understand my name. It does not understand your name. So for example, if there is a column there's a data set for population. Somebody did the survey, recorded the information, and there's a column whether the person belongs to low class, whether in which income group, low class, lower income group, middle income group, or higher income group, which class it belongs. So for that, the person who is doing the survey, they can write low, middle, or high. But this data cannot be fed into any machine learning model. They do not. It doesn't understand what is low, middle, and high. So either you convert into like 0, 1, 2, or you convert that information using one-hot encoding into a set of columns so that the computer can understand it. So whenever you have any column which has text information, for example, it can have gender information, male or female. It can have information for cities, Chennai, Delhi, Bombay, and so on. It can have information about countries. But all that, and this is very common, right? This kind of information is very common to get in data sets. But the computer does not, computer cannot process it right away. It has to be pre-processed. It has to be converted to numbers before a model can be trained on that data set. And ordinal encoding is one of the methods to convert categorical features into numbers. Does it make sense?
Yes, sir. And like, is it like different from hot encoding, or is it the same?
Different from one-hot encoding, is it?
Yeah.
Yeah, it is different. One-hot encoding and ordinal encoding both are different techniques of encoding categorical features. Ordinal encoding assumes that there is some kind of order in which you can put, you can arrange the values of that column. For example, low, middle, high. Of course, you can conveniently write 0 for low, 1 for middle, 2 for high. But let's say there are values like Delhi, Bombay, Chennai. There is no particular. There is, you cannot say, oh, Delhi, maybe Bombay is the biggest city, we should give it highest number. But it might give a different information to your model. You're saying that Bombay is bigger, Delhi is smaller, Chennai is even smaller. Then this kind of ordering, if you give it 0, 1, 2, then you're feeding a different information to the model when this information doesn't exist. There's no such order, right? When there's no such order among the feature values, you always use categorical one-hot encoding. And if there's some kind of order, you can use ordinal encoding.
Okay, sir.
Okay.
One more question has.
Sure.
Yeah. So, like you told that machine learning only understand the number, not a text. So, ordinal can be two type of numbering. One can be that number, and one can be that text. So, both we can use as the ordinal way. like that good, better, best is the also ordinal type of the attribute.
Example. Yes, yes.
And
right.
and yeah, and so what will happen? So if there is a two-way of encoding, ordinal attribute is there. One is the text, one is that number. So how we do before proceeding further?
Sorry, how we are going to ordinally encode numbers?
Like that IMDb rating number 0 to 7 or
Oh,
0 to
right, 0 to 5, that's a numerical feature. That's not even ordinal. So you get 0, 2.3, 4.8, for example. Let me open IMDb. Latest, no, top 10 movies. Right. So if I go to this, okay, it is going to top 250. I just want. Right. Yes. So if you see, look at the ratings, it is from, I assume it is from 0 to 10, and it's in decimal.
Yes. So that's my meaning, was the decimal itself.
Right. So this feature is not, this is not suitable to be applied ordinal encoded. It is already a number.
Okay. So in that case, and this is the ordinal, it is ordinal or it is what?
It is numerical feature.
Okay. So let me change the question. Suppose I created some attribute where I have written that 0, 1, 2, 3, and my number is in the reverse way. For example, who got the first rank is the first, but if you see number way, it is the least. So how the machine will understand the what is what is. So let me frame the question again. In ordinal, I divided two categories. One is the text, where is the good, better, best. One is that number, and number again divided in the two category. One is that number itself matter, which is the better, like that IMDb 9.2 is obviously better than 8.2.
Right.
And second category of the number, I have created some list where I have written some student and participant, and it is the 0, 1, 2, 1, 2, 3, where the 3 is the third rank, 2 is the second, and 1 is the first rank. So this is the reverse. Actually, the meaning of
I got your point. So right. So this one is a score, right? IMDb rating. So let's say you have a movie data set and you want to feed it to computer, then this IMDb rating is already a number. So you will pre-process it differently than a string value. So for example, in a movie data set, you can have other items also. You can also have its, I think, genre. I'm not seeing it over here, but it should be somewhere around here. I don't want to play this. Yeah, there it is. There is drama. Maybe I should go to Dark Knight for a different genre. Right, here you can see action, crime, and drama. Right. So this information is action, crime, and drama. This is to be ordinarily. This is to be treated as categorical features, whether it is action, crime, or drama movie, or all three of them together. And when you talk about the range, for example, somebody got first ring, somebody got the second ring. That is a different. It has a different meaning associated with it. Either you can reverse it. Okay, if you want to give it in increasing order, for example, Shashank Redemption has the highest ring, which is 1. Right, and the Godfather has ring 2. If you want to suggest that, either you can provide it ring, the data set, or you can provide it rating, or you can provide it both of them and expect the model to understand it. Right? Hello?
Yes. Right. Yes.
That is one way to do it. And you can, of course, do feature engineering to reverse it. For example, imagine this. So the problem that you are hitting at is, how do you create features? How do you create interpretable features for the machine learning model? How would you make sure that the model has the right set of features or right type of features to have good prediction problem? So imagine that you want to, you have a data set for observations of force between two objects. Okay, you have their masses, you have their distances, and you have their I should say, what should I call the measurement of force between those two objects. Imagine that this is the experiment we are repeating from Newton's work. Okay. Hello.
Yes, sir. Listening.
Right, and now we already know that the force is inversely proportional to the square of the distance between those two objects, and directly proportional to the product of those two, right?
Yes.
Correct. So, but now you have the entries like M1, you have one column, mass of first object. M2, you have second column, mass of second object. You have third column, which is distance between the two objects, correct? And you have fourth column, which is force, which is, suppose that's your predict the label. That is what you want to predict based on these three quantities: masses of the two items and the distance between those two items. Then you'll have to come up with better features, since you want to predict force. You might want to create some you might want to engineer some features based on M1, M2 and R to get a good set of features for your model to predict the force. Okay, does it make sense?
Yes, sir. My question was the space. I got this thing. One more little more doubt in that. Suppose that I have a one table, and the table has the only three attribute, and all the three column means, and all the three column containing that ordinal type of things. So first column is containing the ordinal variable like that good, better, best. Second column is containing the ordinal variable like the IMDb rating. 1 to 10.
IMDb rating is, by the way, not ordinal feature. It's a numerical feature.
Okay, so take its numerical feature, and the third column, it's taking. I'm taking that this thing. The participant position 1, 2, 3.
Position.
Suppose something position means someone
rank.
Is, or yeah, some position
rank,
in
right?
the position. Yes, like that. 1, 2, 3. 1, 2, 3.
Rank.
One is the best.
Right.
And in the IMDb, one is the bad.
One is the best, right?
No, in IMDb, one is the bad. In third column, there is a listed. I listed the competition ranking. Suppose ranking 1, 2, 3, where 1 means best.
Okay.
And in the IMDb case, 1 is the bad.
Okay. Yeah, right. IMDb, because one is rank, one another is score.
Correct. So once I will do the pre-processing, what we fit transform. So what we will do in the 3 column.
Column number 3, where you have rank, right?
Yeah. So first column containing good, better, best as the text. Second is containing 1 to 10 is the ranking of the movie. Third one is the ranking of the some person or positions. So how
right? That's what I was supposed. That was I was telling you. For distance in the Newton's experiment, you have to create another column for inverse of it. And same here. It depends upon what you want to predict with your data set. Either you can give the rank as it is, or you can invert the rank. Then it becomes, you have to map the rank to a score somehow. Let's say you don't have IMDb rating, you have 1, 2, 3, 4 only. Then either you can take invert of that 1 by 1, 1 by 2, 1 by 3, 1 by 4, and so on. Or you can subtract this column by a very large number, let's say 100 or 200, something like this, so that you invert the rank and create it into a score.
Okay.
Right?
Okay. So all these 3 column I have to take in the same order.
Same order. I mean, order doesn't matter when. Well, you can switch the order, but your model will still train the same.
Okay. Okay. Same order means if one is bad in the third column, then one should be the bad in the second column too.
So again, what I'm telling you is depends upon what you want to predict. What is your label? What is your target variable? And based on that, you can choose whether you want to give it rank or you want to give it a score. Okay.
Okay. Okay. Got it. Got it. Thanks.
Sure. Okay. Let's move to question number 4. Fit transform method on ordinal encoding. I think text numbers. We already discussed this. Question number 5. Mention true or false. Scikit-learn provides a pipeline class to line up transformers in an intended order. True or false?
False.
Okay. How many say false and how many say true?
It's true.
So it's true.
Yeah.
True.
It is actually true, and I'll tell you why. So sklearn provides you a very nice API, which is called pipeline, in which you can stitch together multiple steps of training your model. For example, categorical transformers, numerical transformers. You can put in imputation steps. You can put models, and so on and so forth. So I think there should be a very nice example of this. I'm stepping one step ahead, which it is not. You will know all of this in week 2. For example, you can see that there are multiple steps to be performed on a data set. First one is binarizer, which is basically to convert data pre-processing. And the second step is training a multi-nomial naive-based model. So we've kept both of them together, and as soon as we, I think there it can see, grid search EV is also fantastic use case of pipelines. What I wanted to show you was a very quick, there it is, right? Look at this particular example. We are using Iris dataset, and what the first step is select the 2 most important features from this dataset. This is the first step, and the second step is train logistic classifier. Okay, and when we call fit, which is what we do on any model, for example, logistic regression or anything else, KNN, support vector machine, or any machine learning model, to train it, we call method fit. We give it the samples, the feature matrix, which is iris.data, and this is the label vector or target variable, iris is a target. This is what we do on any estimator or any machine learning model. But look at this. Here it is a pipe. So first, before applying this logistic regression model, it is going to do this step for you, which is selecting best 2 features out of the available ones, and then train the logistic regression model. So you can club these 2 steps together, and honestly, you can club 10 steps together to create a very complex pipeline. You can even, I'm going into detail of what is going to come in next week, but you can take my word, you can create very, very complex data pipelines with the help of pipeline API.
Is this piping a part of feature selection?
Piping is not part of feature selection. Feature selection is part of piping. The other way around. Right. So basically, in a machine learning, when you are creating a machine learning project, all the steps that you need to perform, from imputation, data cleaning, imputation, feature selection, feature engineering, and then training your model, all of these can be clubbed together into a single object, and you do not have to perform all the steps individually. All you have to do is call that pipe.fit, and it will do everything for you in single go. Does it make sense?
Yes, sir.
Okay. So again, if you do not understand how pipelines work,
but so how is it helping if you do it in? I mean, if you put it in separate lines, that will be more readable, right? Than putting it all in one function and getting it to run. I mean, or this is better. I don't know.
See, it is still readable. By just looking at the code, I can find out which step is doing what, right?
Okay.
So imagine that there were 10 steps inside this pipeline, right? And one step, whatever the output of that step is, goes into the second step. Whatever the output of second step is, goes into the third step, and so on. This is the idea of pipeline. You connected actions that you have to take, right? Now, either what you will do is, okay, you will call this object select k best fit on the RS data set, and you will then store into a temporary variable. Then that temporary variable will represent the data set that has to be fed to logistic regression. Then you will create CLF is equal to logistic regression and pass that temporary variable into it. That is more actually time consuming and not that clean. Pipelines are cleaner, and they also take a smaller amount of time for creating or training your model. And one more benefit, which is not obviously visible from this example, is what about making predictions? You want to make prediction on test data set, you'll have to perform all those 10 steps on the test set to get a logical correct output, right? And pipes are going to actually make your life easier, because this same pipe can be used on pipe.predict on test set. All the pre-processing steps, all the steps which come between start to finish will be executed by this pipeline.
So this function is giving what output? The name of two features, the most important features. Yes.
The select k best, yes.
Okay.
So as of now, if you don't understand it, that is okay. I just gave you a glimpse of what is going to come in week 2. But as of now, yes, the correct option is true.
So one question.
Yes.
It says the word transformations. What does it mean?
So transformation is again all type of data pre-processing, all types of numerical feature transformation, categorical feature transformation. Creating transformation is basically changing the state of your data. So either you transform the data by by doing, let's say, if you have numerical data, then min-max scaling. You either change the state of your data by imputing, right, filling the missing values, by creating new features. All of these come under data transformation.
Even in encoding?
Even encoding, yes.
And so what are transformers and estimators?
So estimators are the models, right? Basically, they estimate something. They are not just transforming the data. So, for example, the machine learning model APIs, they come under estimators.
Like logistic regression and
yes.
And transformers, it's just a data preprocessor.
Right.
And last question, in the pipeline, we cannot put estimators, right? Or
sorry?
In pipeline, can we, you said in pipeline, we do data preprocessing. Can we also put estimators in pipeline?
So machine learning models are supposed to be the last step of a pipeline, right?
Yes.
So you can definitely put machine learning models inside a pipeline, but they have to appear at the last. So the examples that we saw, all of them actually, logistic regression, you will see, for example, this one, multinomial naive Bayes. This is also a model, machine learning technique. If you see this one, reducing dimension, PCA comes first, and next comes is the support vector classifier, which is also a model. So all the estimators have to be at the end of the pipeline.
Okay, sir.
So here the estimator will include the training, loss, and optimization. Sir.
Sorry?
So when you say estimator, the fit model, we are including the training part of it, the loss calculation, and the optimization part, the gradient descent. Is that how it works, or
hello?
The loss yeah, am I audible?
Yeah, you're audible. I think your voice dropped a little.
Yeah, so there is training, there is loss, and there is optimization, right? There are 3 parts.
Training, loss, and optimization. Yeah, there are 3. These 3 are components of machine learning. Yes.
Okay, so and all the 3 come into that estimator, the term estimator, is it?
Loss, training, and what is the last one you said?
Optimization.
Optimization. Optimization definitely comes under estimation. estimators, loss optimization. And loss is a function. Loss is, I mean, I don't think that's an estimator.
Okay.
Yeah, loss
Okay, so-
cannot be loss functions cannot be estimates, I think.
Okay, so after we run the fit model, the fit function, you're saying we won't get any loss out of it. I mean, the loss calculation has to be done separately, is what you're saying.
No. For example, support vector classifier and where is that logistic regression. Some loss functions are internally defined, right? So if you don't provide any loss function explicitly, it is going to use the default one. I think we can find that also. If you don't provide any loss function, which loss function it uses. See, by default, no penalty. Solvers are there.
It will be returned, right? Or whatever will be the return.
Sorry?
Attributes, yeah, attributes.
No, these are the attributes are not going to be, loss is not going to be inside the attribute.
Okay.
I think score function is there, which gives you, yes, there it is. Score function is going to give you its performance. So by default, it is going to return mean accuracy.
Okay.
Okay,
sir.
All right.
Thank you.
For the OPE exam, do we need to, would they be modeling, or it is just standard programming using NumPy and all in the OPE?
It will be both.
Okay, we have to learn all this. Okay. Because
Yes, it will be both.
Okay.
So I can tell you what is going to happen in your OPP, but let's finish this one. We are at the second set of activity questions only. There are 6 to finish. Yes.
Sir, one more question, sir, related to Ordinal. So there was a cons, sir. So Sir was explaining the PPT that it was not able to relate to adjoining values. Can you explain that from the lecture?
Sorry, can you please repeat your question?
So while explaining the ordinal encoding, right, there is a statement. So why we go to one-hot encoding from ordinal encoding to one-hot encoding? There was a con he was telling that it was not able to relate to nearby values.
Two nearby values. Sorry.
So see, the thing is, he was telling that there was an issue with the one-hot ordinal encoding. Because ML would assume that two nearby values are closer than the distinct ones.
Right, absolutely.
So what do you mean by that? Because ordinal anyway it is ordered.
Okay, sure. So let's say you have a column which is either, for example, if we have, I think we talked about this example, low, middle, and high. Were you there?
Yes.
So right, so low income group, middle income group, high income group. There's a order. We can say that, okay, if we assign rating or some kind of a score, we can say lower income group is 0, middle income group is 1, and higher income group is 2. Right? We can give them such kind of order, or 10, 20, or 30, but whatever suits us. But typically 0, 1, 2, or 1, 2, 3. Right? So whenever we are saying that somebody has income group 3, that means there's definitely that person is earning more than somebody who is in income group 2 or 1. Correct?
Yes.
So this is the order. This is a logical sequence. But imagine that we have a column with cities. Bombay, Delhi, Chennai, right? Then we cannot say one city is greater than the other city.
Okay. It was not able to relate.
Right. So for that reason, we use one-hot encoding.
Okay, sir, got it. Okay.
Sure. I think for this question we dropped this drop.
Sir, I have one question.
Sure.
Sir, when we have large number of features, So is it necessary to reduce the number of features while training, or we can include all
well,
the
it depends.
features?
Well, it's up to you. How much? By the way, when you say large number of features, how large?
Means 50, 60, like that, or 100.
How many number of samples you have?
Samples are approximately 10,000, like that.
This is a very small data set.
Oh,
for modern computers.
Okay. So I thought that it is because while opening the Excel file in 1,000, 2,000 data, I get lost. So 10,000 looks big to me.
Right. See, so for computer 10,000 or 10 million, it is going to just run a loop, right? The amount of code that you have to write is going to be nearly same. But for training the model, it's going to be a different picture. So imagine a situation where you have 1,000 features and 10 million rows, 10 million samples. Now you definitely want to reduce number of features to reduce your computational time. I mean, the amount of time that you need to train your model for. Correct?
Okay.
And of course, then you want, let's say you have 1,000 features, you want to remove the features which are not adding any value. Correct?
Sir, is it possible that features might interfering with each other and model is not getting trained well?
What do you mean by interfere?
Interference means that features themselves are preventing them to train the model.
How a feature can prevent a model to train from from training?
Okay. Suppose two are highly correlated.
Correlated features. I mean, if they are very high, let's say correlation is 0.9 or 0.95, then basically one of them is useless, right?
Okay.
So you can remove that.
Okay, sir.
Yeah. So that's what PCA is, right?
Okay, sir.
Principal component analysis.
Sir, just another question. Sir, just blindly following the PCA or any K-based thing, it will automatically give me the right options, isn't it?
No. How would you blindly follow it?
Suppose while in the pipeline, I put up the PCA for the feature selection. And so it will automatically with the default parameters, so it will automatically choose the correct number of features.
Correct number of features, the number of features you have to provide it.
Okay.
It will not automatically choose it.
Okay.
Can I tell something?
Yeah, sure.
Yeah, but PCA doesn't choose that features whatever we provided. They create the new features where the most of features going to become in the first PCA component, then second PCA. It's like that. So they're calculating the many things before choosing the PCA feature.
Absolutely right. Absolutely right. So principal component analysis, PCA technique is going to give you a new set of feature,
Yes.
I should say vectors. I mean, it is going to transform your data into new space altogether.
Yeah, which is the most optimized and the very the first component itself is containing the most of the feature, and the exponentially it's going down.
Right. So what you want to say is the first feature in the new space captures the most variance. Right?
Correct. Most variance, and it's going down. So after certain percentage, we ignore after that feature. So we have
right. Yes,
that is the way. And PC itself is a huge calculation is happening, matrix, eigenvalue, eigenvector, covariance, and then they do process further thing.
Right.
So it's not randomly choosing the some features.
Correct.
Mean square error should be there.
Sorry. Oh, so you're talking about the question.
Sir, just last question regarding the feature selection. Sir, when we apply the info method, describe method, then we get the data statics. and there we get the standard deviation. And suppose in my data set, certain features are having large standard deviation. So can I choose only those number of features which contain higher standard deviation? And suppose any feature having standard deviation 2, 3 like that, so we can ignore them. Is it a good?
No, it's not a good method, because standard deviation, whenever you're calling that method, standard deviation is across that feature only. It does not explain how it is connected with the target variable.
Okay.
So you cannot say it is very important. You cannot say it's not important.
No, suppose the data itself is not varying much, so it will not
Which
impacting
data?
the label.
The feature or the label?
Feature. Any feature column, any individual feature column, if it is not having any deviation, so it won't be affecting the label much.
Well, again, I would say you cannot just by looking at a standard deviation or variance to variance of that particular column only to figure out how it is related to the final label vector. Well, one thing I can say is, if it is, for example, all the values in that feature is same, then it doesn't matter to include that feature. One is that, and second is, of course, there are very few sparse unique values. Rest of the values are same. Then it is possible that it is not useful. But these techniques will come in data preprocessing week 2.
Okay, sir. Just I was having some doubts. That's why yes, sir.
Okay, sure.
Okay, thank you, sir.
Okay, let's get back to 1.3. Which of the following can be used as an evaluation measure for regression models? Pipeline, condition, mean squared error? Definitely mean squared error. Pipeline is an API. Condition matrix used for classification. Mean squared error is the right one. Question number 2. Mention true or false. Cross validation provides a separate mean squared error for each validation set. True or false?
True.
That is true. Question number 3. Building a model on top of another model is called
ensemble.
Right. Question number 4. What is the remedy for underfitting? To have less constraint regularization, to have less regularization, to have more regularization, delete significant portion of the data. Wow.
Less constraints.
Yes. Less regularization.
Why, sir? Why, sir?
Pardon me?
Why the less constraints?
See, underfitting means your model is biased. It is possible that you have overdid the regularization, and that's why you want to reduce the regularization to remove underfitting.
Okay, regularization reduces overfitting, so by overdoing it, it went on to become underfitting.
Absolutely right. Yes.
Okay.
I think all of them should be right. Yes. So next set of activity questions are on hyperparameter fine-tuning machine learning models. Okay. So first question is, grids as CV class is part of which library? Pillow, scikit-learn, NumPy, or Beautiful Soup?
Scikit-learn.
Absolutely, it is part of scikit-learn. Pillow, I think it is used for images. NumPy is for linear algebra matrices. Beautiful Soup is for web scraping or accessing document object model of HTML pages. Question number 2. Which of the following are the hyperparameters in the random forest regression? Number of estimators, maximum number of features, precision, and recall.
The first and second.
Okay. Why first and second, not the rest of the two?
I mean, that is the derivation, precision and recall.
Precision and recall or evaluation parameters for quantity.
Absolutely right. Absolutely right. So, first and 2 are the correct answers. Question number 3. Mention true or false. Initializing grid search CV with refit is equal to true option retains the best estimators on the full training set. Is it true or false?
So what does it mean?
Okay, so do you know what is grid search CV?
No, sir.
I see. So grid search CV.
Parameter optimization.
Yes, grid search CV actually is used. So okay, let me give you a situation, hypothetical situation. Are you aware of linear regression model?
Yes, sir.
Okay. Are you aware of? Are you familiar with its regularization?
Yeah, kind of.
Okay. Okay. So you have to choose a regularization value, right? Regularization, which is called typically, which is represented by lambda. What value should you choose? How do you know what is the best value for lambda? Hello?
Yeah, like we have to try different values and see.
Absolutely right. You have to try a set of values and pick the best one, right? So that thing is done by grid search CV. Let me show you its documentation. Exhaustive search over specified parameter values for an estimator. So maybe we can find an example over here. So if it were linear regression model or ridge regression model to be specific, okay, here you can see that there are 2 parameter grids. So this is for I should say support vector machine, I believe, right? Support vector machine. So here what I'm saying is there is one set of parameters is try linear kernel, and these 3 values for inverse of regularization rate. So C represents inverse of regularization rate. And the another set of parameters that I want my model to be tried with is use RBF kernel and then use gamma parameter values to be these 2 and these value for C. These values for C parameter. I think this is called regularization strength, something like that. So where is it? I'm not seeing a particular example out of it, but definitely this is how you provide a set of parameters to be tried out in exhaustive manner. So grid search CV, for example, for linear kernel, it is going to try C value 1, C value 10, C value 100 and 1000, and will record the best one. And the second set of parameter grid, it is going to try RBF kernel with gamma value 0.001, and then for that gamma value, it is going to try all these 4 values of C. And in next run, it is going to take gamma value this one 0.0001 and then all values of C. So it is going to try put I should say exhaustively search through all these set of parameters to get you best set of hyperparameters.
So
okay.
we give them like a lot of estimators here. Like we're using different estimators here. So we can give decision tree, linear regression, several estimators, and it will pick the best estimator out of those, right?
First estimator out. Sorry, can you please repeat?
So we will give like several estimators in the grid search CV. So we can give decision tree, we can give logistic regression and linear regression, and from that it will choose the best estimator. Is it correct?
No. It's not about estimator. It is about, of course, if you can put grid search CV for figuring out the best estimator, you can use it for that. But for a given estimator, what are the best set of parameters that you should use? Grid search CV is explicitly for that.
So it will. So here in the example, we are using 2 estimators. So it will provide answer for both the kernels, right? Which is the best estimator for linear as well as RBF.
It is going to provide actually among all these. What is the best set of parameters? What are the best set of parameters? What is the best value of C, kernel, and if gamma? If kernel is RBF, then what is the best value of gamma?
Okay.
Okay, makes sense?
Yes.
I think the answer for this should be true. True option. It is the best parameters on the full training set. Yes.
If you don't put refit is equal to true, what will happen, sir?
Then it is the best set, the best parameter. Sorry, the best model or best set of hyperparameters. It will not train on the entire training set. You will have to do it explicitly.
Okay.
Question number 4. For a large hyperparameter space, it is desirable to use which of the following options? Randomized search CV, grid search CV, my CV, stratified CV.
Randomized.
Randomized. Absolutely right. Randomized means so whenever you give it some set of a parameter grid, it is not going to run for each and every point in this grid. It is going to randomly select and run on them.
So what is hyper?
Of course. What is hyperparameter tuning?
No. Hyperparameter space.
Hyperparameter space means for if you take ridge regression, for example, then value of that regularization rate, lambda, all the values it can take or set of values that you provide your randomized search CV or grid search CV to try it with, it's called hyperparameter space. For example, here the hyperparameter space for C, we are defining it to be only these 4 values, 1, 10, 100, and 1000. Out of these 4 values, give me the best one, right?
So only like from these only, like no other value can.
You can put more values to it. If you want to run it for larger space, you can do it.
So it will only give one of these values, like not other value.
Sorry?
So like the grid search CV will give values from this list only. It will not give any other value.
No. If you are giving it only these values, then it is going to give you best of these set of values. Okay?
So.
All right. Let's check our answers. All of them are right. Any questions so far? We are going too fast, and I'm pretty sure you have a lot of questions, a lot of curiosity. What is this? What is that? Definitely, that is natural. But some of these, since the first week is giving you the overview of the entire machine learning end-to-end process, there are a lot of things for you to learn, new things, but they will become clearer. There will be more detailed explanations on those in later weeks. Okay. Any questions so far?
Sir, I have one question regarding the hyperparameter tuning. Sir, while executing this grid search CV, so if we take number of basically large data set, so it takes a lot of time to compute. It means computer it 4, 5, 6 minutes, more than that. Even one of the algorithm, it doesn't execute it at all. I tried many times, but it didn't execute it. So how to optimize that?
So see, either you can choose smaller grids at a time to execute in a 5-6 minutes, training a model in 5 to 6 minutes. I wouldn't say it's large. It's a long process. You can have data sets and corresponding models that can take weeks to train and optimize hyperparameters. So 5 to 6 minutes is okay. And for the model, which is you're saying that is sticking, it's not able to give you the correct answers even for hours. You can try it with a smaller parameter.
Okay, but sir, that smaller limit won't be the best limit, isn't it?
So then you have to repeat this process again and again with different set of smaller grids.
Okay, range I have to define in a smaller ranges.
Yes.
Okay, sir. Okay, thank you, sir.
So first question is, different types of SQL objects are estimators. Okay, what should be there?
So what are predictors?
So predictors are the objects which have dot predict method in them or fit predict method in them.
So first three.
Right, first three. Question number 2. Mark the correct statements. Predict method takes a feature matrix as an input and returns predictions. Okay. Option number 2. Score method measures quality of predictions for a given test set. Okay, let's go one by one. What about the first one? Is it true or false?
True, sir.
It is true. Option number 2, score method.
So it gives the accuracy.
Yeah, it gives you accuracy, or any different evaluation metric can also be used.
I think it should be true then.
It should be true. Option number 3.
That's false, and that should be used on the
Fit
training.
transform used on test data. Fit transform. No, it's not. It's only should be transform. The transform method fits the parameters and uses them to transform the data set. Is it true or false?
It's true.
True or false?
It's true.
Right. So fit method typically learns the parameters of either transfer or estimator, and the transform function only does the transformation. It does not learns the parameters. So whatever fit transform. So there are 2 steps: fitting, which involves learning the parameters. Transform means applying using those parameters and transforming the data. Okay, so these are the 2 steps: fitting and transforming. So fit transform does both of these steps together. Okay, and you can perform the same thing by calling fit and transform methods one after the other, and it will do the same thing. However, transform method, you do not want to use them to transform the data set. I think there is some mistake over here. There should not be no brackets over here. But the transform method is used specifically for on test set. For example, you want to transform your numerical features. Fit transform you can use directly on the training set, but for the test set, you definitely do not want to use fit transform. You only want to use transform, and hence these 3 functions are there: fit, transform, and fit transform. I hope it's clear.
So, but technically, when you say fit the parameters here, are we talking about, let's say in case of linear model, are we talking about the W's and
no, fit
the lasso parameters and so on, the ridge hyperparameter? No. Are we talking about that, or is it something else?
So this fit transform and fit transform methods are inside transformer objects. For example, that think about scaling, think about categorical one-hot encoding.
Right.
For that, with those transformer objects. So, for example, you want to apply min-max scaling on a numerical feature. You definitely want to fit that on training set, not on test set. Right? Right, because you want to learn the min-max scaling on training set. What are the internal parameters are? Basically, minimum value and maximum value. You want to make sure that test set is also on the same scale. So you only transform the test set, not fit transform. Does it make sense?
Yeah.
Okay.
So fit is used when there is no transformation needed?
Fit is used. No. Yeah, you can say that. So fit methods are in predictor objects as well as in transformers. So fit method in predictors of objects is going to train the model. Fit method in the transformers is going to learn the parameters of the transformation.
Okay.
Fit basically gives the regression equation of the labeling with the parameters, right?
Well, regression, when you're talking about transformers, it is doing something else.
Yes.
Okay, so let's go to next question. The function of sklearn linear, I think there should be underscore models to implement classical algorithms like logistic regression, linear regression, etc. K nearest, second option is K nearest algorithm, K nearest neighbors algorithm. Third is multi-class classification models. Fourth is multi-output classification and regression.
So first one.
It should be so basically all linear models. Logistic regression, linear regression, perceptron is also there. So linear regression models will be inside sklearn dot linear underscore model. Okay. Question number 4. The function to implement the naive Bayes classification is. Which one is the correct option? Hello, anyone? Hello?
The second one, right?
Yes, the second one. This is more out of memory based. I think if you watch the videos, and many of you did not get a chance to watch it. If you watch it, you'll learn it that this is the name of the naive Bayes API.
So this is just a syntax kind of thing, right? Because all of them are the same. If we don't know the syntax, we can just go wrong. I mean we just Googling it and we can just find the correct answer, right? Because technically, if you just want to memorize so many things, then it will become difficult, right? Because
I see. I wouldn't say that you will have to memorize. As long as you keep, as soon as you start using them, it will become part of your muscle memory.
Okay.
Right. Question number 5. So see, I have used linear regression models or linear models many times. So I remember that sklearn dot linear underscore model is the module in which there are a bunch of linear models, basically. All linear models are over there. So you will remember sklearn dot tree will have decision trees. You will remember these things. No need to worry about it. Since when you work on the problems, when you type in the code yourself, it will commit to your memory. You will feel this. But since it is part of question, it is important for you to know that this is where naive Bayes APIs are. Okay.
Yes, sir.
Question number 5. Suppose we use the following code for creating a random data set of 10 samples with 2 features each. What is the Y or label vector?
Fourth option.
Fourth option.
Yeah, because there are 3 centers.
With 2 features. Okay. Suppose anybody else? It is your answer is actually correct. Make blobs. N samples is going to give you a number of rows in your data set. I'll come to centers also. N underscore feature is going to tell you number of columns in the feature set, number of features that you want to have. Random state is going to give you some reproduce. It is used to reproduce your results. Make blobs. This is going to decide the label. Okay, if you want to read up how, so many of you did not get a chance to watch the videos, but if you see it, well, this is what you will find. Okay, let's move on to the next question. Which of the following is a supervised learning problem recommending relevant product ads to website visitor based on previous purchases, or product search made on the website. Option number 2, you have been given heights of different students of the class. You have to group them into 3 categories: tall, medium, and short. Third option is a bank looking to decide the amount of personal loan to its customers based on transactions in their account. Fourth is robot has been placed in one corner of grid with 3x3 grid. The grid world has an obstacle in the center and the goal in the other corner, diametrically opposite to the agent. There is a reward of +3, -1, and -10 for reaching the goal, 1 step in any direction, and for hitting the obstacle. So which of these 4 options is represents supervised learning?
So 3.
Sorry?
Third.
A bank looking to decide the amount of personal loan to its customers based on transactions in their account. Okay, this is a candidate. Okay, let me remove the second one because it's basically clustering. Supervised learning, that means you have labels also. Recommending relevant product ads to a website visitor based on previous purchases or product search made on this website. This looks more promising, right? Because what have you already? Let's say you have purchased Nike shoes or T-shirts, and based on so the company or the website already knows this, and based on that, it is giving you let's say advertisement of latest Nike shoes or latest T-shirt. I think this is definitely supervised.
So it is shown third as the correct option.
Right? Sorry?
So it is shown third as the correct option. Why? There is no label in third option.
Right. See. I think which of the following is a supervised learning problem? Okay, so there might be a one case like recommendation systems can recommend you things which are not based on your history of purchases or website visits. I think I missed that point, and that's why I marked this. But this can also be a good candidate because if you look at the transactions of the customers who successfully return the loans, you can definitely choose the, option number 3 for posing it as a supervised learning problem.
So there are no labels.
You're right, there are no labels, but there are transactions, right? You have some information about their transactions in their account. Based on that, you can choose whether to give loan to this person or not.
I mean, the label could be that based on the transactions, all the past amount of loan that's given.
Right, right. So the label would be, so features would be information on transaction, and the label would be whether that person returned the loan successfully or not. Does it make sense?
Yes, sir.
Okay.
And the fourth is a reinforcement learning problem, is it?
That is absolutely right. It's a reinforcement learning problem.
Okay.
So what is reinforcement? I mean,
so reinforcement learning is you get so it's formulated in a different manner. It is specifically for I mean not specifically, but very useful for creating very intelligent games, game players. You might want to read up on this one.
it's neural networks or something.
Not neural networks. AlphaGo documentary, I would say. You should definitely see this. So imagine you are playing chess, right? So you are playing with white pieces. So you make a move, the other person also makes a move. Then the computer, how would it decide which move you should play so that you are going to win? because you do not know what the black is going to play next to you, right? But you probabilistically create an simulation of the environment, model of the environment, and based on that you decide. And also you do not know in how many moves the game is going to be over. 20 moves, 30 moves, some games last 40, 60 moves also. So you don't know. And you want your model to give you an action. It doesn't want you, you don't want to, get a label out of something. What is the best action?
So would Google Maps be part of reinforcement learning?
No, Google Maps is, no, it's a graph data structure.
Okay, sorry.
No. Okay, let's move on to next question. Question number 7 is recommending relevant product. Okay, which of the following is a regression task? Recommending relevant product ads to website visitor based on previous purchases or product search made on the website? Definitely no. In regression problem, always remember that the label has to be a numerical value, and that's all. Option number 2, you have been given heights of different students of the class. You have to group them. Definitely not. I think 4, the 3 options we have already seen them. A bank, okay, it is slightly different. A bank looking to decide the amount of personal loan to its customers based on transactions in their accounts. It has already identified potential customers, but now wants to ascertain loan amounts for each customer. Okay, so for example, it wants to decide for customer A should receive 1,000 rupees of loan. Customer B should receive, let's say, 5,000 amount of loan, and this is what it wants. This is the application. This is the requirement. So what you want to decide is a number, the loan amount that the bank should give. So I think this should be a regression task. Now, 4th option is predicting rainfall this year based on the data available for last 30 years. So rainfall is typically predicted in number of inches or number of millimeters for a particular, for measuring how much it rained. So rainfall, the unit for rainfall is number, is going to be a number, millimeters or inches. Therefore, it should also be a regression task. All right, any questions so far? Okay, at this point of time, I'm seeing very small amount of participation. So I'm thinking of not continuing the session anymore. What about we start from, we pick up from where we left in the next session? So that by that time, everybody gets a chance to watch the videos, go through the questions, and this will be much more interactive.
Sure.
So that's a good idea.
I have one question, sir.
Sure.
Yeah, can you tell the little detail about the data set? Because sometimes we see that about the data set, it's come in the SQL, also it's come in the Keras, also it's come in the Seaborn. So what's the actual difference of the data sets and its attributes? And sometimes we see that common database in the all these 3, but sir use something different, sometimes different. Is that any difference or what?
So no. So if data set is, for example, Iris data set, it might come from, for example, digits data set. It might come from OpenML. It might come from Keras. It might come from some other source. But typically, the values are same. The different versions are maintained. These are various ways in which you can import the data into your workspace.
So it's no matter that from where we are taking the data.
Typically, for standard data sets, it doesn't matter. For example, Iris data set, MS data set, they are very standard, and importing them from different sources is not going to create any problem.
So the moment we load the data, so there is a attribute. So it's stay common in that everything, or that variable or value change, not variable, the attribute, the way dictionary they send that. Whenever we call the data set, they send the dictionary.
Right.
So is that dictionary is the same, or throughout that entire the different module, or it's stays same almost?
What dictionary? You're saying the features and the labels?
Correct. Dictionary means whenever data sets come load, then it's come with the features name, features, data, and the also the test name, and many things come. So
okay.
So it's stays same, or the number of features also stays same, or it's different?
The number of features, they stay the same. The standard data set, they stay the same.
Okay. Okay, that was the.
Sure.
So we received the videos only today. So we have 2 assignments for the 18 and already lost 2 days. So shouldn't, I mean, be the deadline be increased by 2 days?
Okay. So Manu, can you please write an email to CS2008 ID, and I'll see what you can do.
The support?
No. The official CS2008 ID. Or you can write to support also. They will bring this to team's attention.
Okay, sir. Thank you.
Yeah. Okay. Preetodeep, I'm seeing that you have raised a hand. Do you have a question?
Yes, sir. Am I audible?
Yes, you're audible.
Yeah, sir, I had a question regarding the MLP project. On 3rd September, I added the course calendar today. Since I got access to the course portal today itself, I added the calendar from there, and I saw that, and I'm seeing that on 3rd September there was a scheduled meeting for MLP project discussion.
Okay.
And that was held on Google Meet. So can we get a recording of that, sir?
No, it was not recorded.
So can you please tell us what happened actually, since we did not know that meeting would take place, and
So
we had no link to that.
So didn't you receive an announcement for it?
No, sir. No announcement was received. Also, I did not have the Google Calendar link, so I could not join the meeting as well.
Okay. So Preetodeep, by the way, that meeting was for students who joined ML practice project last term.
Oh, okay. Then that is not applicable for me.
Yes. Right.
Okay, then sir, just as a side question, can you tell me when the projects for this term will be given? I mean, my course portal still doesn't show MLP project as a separate course as of now.
Okay, so I think it's being created. It should be created within a day or so. Or maybe it already been created. The information regarding the how to join the next term's project, the problem statement, the data sets, everything will be available to you by 10th of September. Does it make sense?
Okay, 10th of September. So in case I do not get access, I'll let you know by then.
Sure, Peter.
All right. Thank you, sir. Thanks for that.
Okay, sure. Okay, thank you everyone. Thank you everyone for joining.
Sir, can you please repeat the email ID?
It's CS2008. Your course name. Course
ID.
Moniker, yeah, course ID.
Okay, CS2008. Okay.
Yes. All right. Thank you everyone. Thank you everyone for joining, and those who have not watched the videos, please go ahead and watch the videos and be prepared for these questions. We can revisit the questions if you have any doubts in the next session also. And welcome to ML Practices course. And hope you enjoy this course.
Thank you, sir. Thanks for the session.
Okay. Bye. Have a good day.